All right, so this is kind of what's on tap tonight. Obviously, we did introductions. Got a couple videos that we'll show you on Chief and on the metal building industry. We'll get to talking about how we produce things, different people that work in this building, project managers, engineers. We'll talk about our programs, our MBS, metal building software, how that works and how it's involved with us. We'll get into some math. We'll talk about our other programs, AutoCAD and Bluebeam, and then we'll finish the night talking about our work environment, how this is a career and what it takes to be successful. All right, very good. All right, so that second video was just a little bit of a taste of Chief and the different organizations that we have. We have 7 different business units, including a corporate office, and we are the buildings division. That other video on metal buildings kind of gives you a little bit of a taste of what we do and a little bit of the history of how metal buildings got started. Some interesting facts. I think that if you caught it, just how recyclable a metal is and a metal building is. And so we're pretty green. Another thing of how popular it is, just about 50% of all commercial low-rise construction in the United States is metal buildings, okay? Now that's commercial low-rise, okay? So that's a good statistic. The speed of how these things go together, and the reason for that is because we design, detail, and manufacture basically sort of, I like to say, under one roof, okay? Other types of construction might involve an outside engineering source or an outside detailing source. All that is done under one roof. So that's kind of some of the uniqueness of us. All right, this is a slide prepared by MBMA, Metal Building Market, and it's just showing the types of buildings and how much a percentage in the last year. So you can see, commercial's the biggest with 37%. What's that include? Retail, offices, dealerships, warehouses, etc. Coming in second, manufacturing, warehouses, production, things of that nature. I think interesting out of that is how small agriculture really is. Metal buildings, when they kind of got started, it seemed like they were kind of a farm storage farm shop. Not anymore. It's really used for commercial and manufacturing, recreation, educational, anything. All right, so this is another little overview map. All those pins on that map is just showing where we shipped buildings last year. We do ship to all 50 states. You can see where it's a little heavier. That's because we have manufacturing facilities right here in Grand Island. We have another manufacturing facility in Rensselaer, Indiana, which is about an hour and a half, 2 hours south of Chicago. And then our newest manufacturing facility is in Lancaster, South Carolina. That's pretty young, about 3-4 years old is all. And so that's kind of where we ship and kind of talks about our growth and where we're trying to expand. Likewise, I'll just mention, not only do we have this office here for drafters and engineers and everything here, as you've seen, our Lincoln office that has engineers and drafters. We've got an office in Fort Dodge, Iowa with just drafters. We've got an office down in Hastings with drafters, and we've got an office in Eufaula, Alabama as well. Over to the right, you see the O'Reilly, the Dollar General, and the Tractor Supply. Those are just some kind of name brands that we sell to. O'Reilly is kind of a private account. We sell directly to them. Dollar General, we've got our builder network. We probably do 40, 50 Dollar Generals every year. We probably do about 70 O'Reillys every year, and we usually do about a half a dozen Tractor Supplies every year. All right, so this is just some pictures of some finished product. Gives you an idea of, just the different types of structures that we can do, the different claddings or exterior finishes that can be put on a metal building as well. All right, we'll get into a little bit of terminology, and this stuff is in your book. I always say we have our own little language, and as we get deeper into it, you'll kind of see. So this is just a skeleton of a basic building. You can see the eave height, base spacings, which is going from column to column, or sidewall or end wall to column, building width, building length, our eave line, our frame lines, etc. All right, there's a little bit better picture that shows even more. So you can see our frame lines. You can also see how they're tapered. The reason they're tapered is because they are designed as a one-off for each building. And unlike conventional steel, we put the steel where it needs to be. So, and the reason we do that is because it's all 3-plate and we weld it together. So we'll put the steel, it doesn't need to be like at the base so much, so it's narrower there. And when it gets to where the column and the rafters connect, which we call the haunch or the knee, then it gets thicker or wider. Girts, our secondary members, I should say, are our purlins and girts, and they are primarily Z members. They can be C members shaped. They are cold formed steel that comes out of a coil and is roll formed out over at the plant. Other notable are corner posts, end wall posts, framed openings for overhead doors and walk doors, our wall panel, roof panel, and then we get into trims, gutter, corner trim, etc. All right, so this puts it, I think, in better perspective because this is an actual building. So you can see what an end wall looks like, what we're measuring from the eave height, from finished floor, or in this case, the ground, up to the top of our eave strut, what the eave is and the gable and the peak, sidewall, end wall, building length, building width. All terminology that you'll need to learn. And we'll keep talking about these on our Saturday sections. All right, so this is a 2-building complex, what we call. Obviously, when it's all put together, it's one building. But we break it down into 2 buildings. You can see the taller building, building A, lower buildings, building B. But again, it's showing you where the width and the length, the sidewall, the eave height, how that's all in proportion, the peak, the gable, everything. This little building's got some cupolas on top, which is cute. It's got a dormer, which makes it pretty fancy. All right, so looking from the inside now. Again, same terminology, same things, but now you can see what we're talking about, maybe even a little bit better about our Z girts, where our eave strut is, our rigid frame rafter and column, door jamb, frame line, etc.
Good job, Boyd.
Thank you.
All right, we'll see you guys. We're going to get in and start talking a little bit about what it is that we actually do inside this building and inside of our other offices that Dwayne talked about. So what is it that is actually what Chief is providing? You see listed there, design, that is our engineering staff. We have about 20 engineers, I believe, on staff currently, spread out over multiple locations. Detailing, that's what we're doing here and what we're going to talk about. This is what we like to say in this group anyway, is this is where all the work really happens. We take the design from the engineer and we turn those designs, those sizes that they're telling us to use, and we're actually putting those into plans that go to the field to be erected and to go to the shop for the shop to make all the parts and pieces. We'll get into seeing a little more of that. But then fabrication, that's the three manufacturing facilities that Dwayne mentioned. They take all of the information that drafting gives to them and they build the parts and pieces that get loaded on the truck and go out in the field. So as drafters, we like to think that we have multiple customers. Our two customers really are the erectors in the field putting the parts and pieces together, and then the personnel in the shop that is making the parts and pieces. So we have two sets of drawings, the fabrication drawings and the construction or erection drawings. What do those consist of? Obviously, anchor rod plans. Those are we like to think that's the most important first element that we get in the builder's hands. We don't design the concrete. We give reactions and we give anchor rod placement drawings, and builders take those and they take it to a concrete designer and they design all the foundations and footings. So it's important that we get those out in their hands as quickly as possible. The permitting drawings, obviously that is critical for the builders to be able to get all their permitting issued, get everything in place so they can start working out in the field. And then the erection drawings come later after drafting does all their fabrication drawings, ships those over to the plant, then we send drawings out to the field on how all the parts and pieces go together. And we'll show you some examples of those coming up. Those fabrication drawings for the plant, they consist of those shop assembly drawings and also building materials. So basically every bolting clip, every bolt, every screw, every piece of trim, mastic, all that has to be listed out on a bill of material so they know what to load on the trucks. And then if there's any items that we don't manufacture in-house, we're seeing more and more, like the video they talked about, the insulated wall panels. Well, that's a very specialized product that we don't manufacture those. So we do provide cut list items that go out to that manufacturer. So basically it is provided by Chief, but it's manufactured by an outside source. So here's a little flow chart that kind of shows what happens when an order gets placed with Chief. First thing, their sales. We have a network of about 400 Chief builders across the country that primarily sell just Chief buildings. We also have, I believe, 10 district managers or salesmen, and they are divided up in territories around the country, and they work with those 400 builders to keep us busy, and we work to keep them busy. So it's a nice balance there to help each other out. But the sales department, they create that initial contract. That's the builder and customer working with our district manager. We have an in-house estimating department that does all the pricing to get these projects sold. We have a project manager in-house. I believe there are 8 of those individuals on our project manager team. They're responsible for creating those contracts, that ATP, that agreement to purchase. That's our document that basically tells the builder, this is what you've ordered, this is what we're going to provide. Engineering. Obviously, they're the ones that are doing the sizing and calculating the member sizes and connections. I like like to kid them and tell them that actually the software does all the work. They just like to kind of justify themselves by tweaking things a little bit here and there. But since none of us are here, I can get away with a statement like that. But they calculate the connection requirements, all the material has to be sized, and you'll see in the drawings that it's critical that those parts and pieces go in the proper place, because two parts might look exactly the same, but where they're located on the wall or the roof, they could be different thicknesses, different material requirement. And they create what they call a design package, and that's what drafting uses to do the real heavy lifting here. So the first step is the MBS drafter. That is the individual who is creating those initial drawings and manufacturing documents. They run this MBS metal building software, and it interfaces with the design. This package, the software package, is all inclusive. It is a estimating for pricing. It does the engineering, and it also does drafting, erection drawings and manufacturing drawings. It all comes from that single source. Next step is your detailing drafter, and that can be the same guy who ran the MBS, or it might not be. But that detailing drafter determines the parts and pieces for the building, creates the final erection drawings, and creates the final fabrication drawings, documents that go to the plant. So it's critical, all of these parts and pieces, you know, Dwayne talked about how fast these buildings can go together. We don't want to have any problems. We don't want to have any field welding. We don't want to have holes that don't line up. So it's critical that all these parts and pieces fit together nicely and bolt together. There's no field welding on any of these projects anymore. So everything has to be accounted for, and we do a lot of checking for interferences and clearances, make sure things fit. We don't like getting surprised with shop or field calls that there are errors happening and things aren't holding together. So that's a critical step in the whole process. Manufacturing, those are the guys across the street that are taking all of our fabrication documents and actually building these parts and pieces and loading all those materials that are required on the truck. Shipping, you know, Chief has we have our own shipping department, our own shipping division that ships a lot of our products, both outgoing freight into the plant and incoming materials that get fabricated into parts and pieces. So they're delivering those parts and pieces to the job sites. The builder then takes all those parts and the drawings that drafting creates and puts all the parts and pieces together. You see a picture there of an in-process building, and then the final project received by the customer. So drafters work a lot with the project managers. Like I said earlier, the project managers are the ones that are responsible for that contract between the builder and Chief. They are basically our source of contact. If we see any discrepancies in the order, anything with the design that isn't quite lining up with the offer to purchase or the contract, we will go to that project manager and try and work those issues out. Drafters typically aren't in contact with our end customers or our builders. We let the project manager be that one source of contact. But you see example here of our order form, and that basically describes everything in that building. And it all leads back to that terminology that Dwayne was talking about and showing you the pictures of, you know, the eave heights, the claddings, where are the openings, all those things. See a picture here that's a pretty complicated building with a lot of special features. You know, some canopies, some, we got a little projection up above the roof, a dormer, some hips and valleys. Those are all very challenging things for a drafter to deal with and make sure that everything bolts together when it gets to the field. Interesting project here. I believe this is a fire station that went to Martha's Vineyard, which is an island, everyone knows that, and everything on this job had to be ferried over there on a boat. Turned out really nice. So again, another example here of part of our contract documents. This is kind of how the building is defined. You see there, you know, unsymmetrical or symmetrical building A, 70 foot wide, 220 foot long, 22 foot eave height, 3 on 12 roof pitch. The bay spacings are defined there. And then you see building B is a lean-to, it's 30 foot wide, tying onto the side of this building. Nice to see the picture of the actual building so you can kind of get an idea of what all that information, how it relays into actual dimensions of the building. Again, more examples of the same. Little building here with some framed openings, some wainscot, which is a different colored panel down low on the wall, even gable extensions, and again, tying back to our contract documents, how all of those things work together and how they describe that project. And part of being a drafter here is we teach you how to interpret, read all of these documents. I will mention we have a pretty extensive training program. We don't just throw people out into the production world right off the bat. It's several months of in-depth training. We have you pretty confident when we move you into production world. Not everything can be clearly defined on our order documents, so sometimes we have architectural plans that come in with our contract, and the project manager will go through those and include pages that are applicable to the project for all the personnel that work on it. You see some examples here of some notes that have been added. They pull these into a PDF editor and add some comments, maybe give further defined areas that are in question. We also work with engineers. Like I said earlier, the engineers are the ones designing the structure. They size all the parts and pieces and put it into this design package, and that is the document that drafting uses to size and make sure all the parts and pieces fit together. Picture here of a hangar building. That is a 300 foot wide aircraft hangar. A little hard to see maybe, but this in-wall view, that's going to have a very large opening, probably a rolling or stacked door. If you can look close at the top and get an idea of perspective about how big this project is, you see those guys up on the lift there. Those columns and rafters are about 6 foot deep, which is close to the limit of our manufacturing capacity. So yeah, that's probably a 50, 60 foot tall building. Again, another example here of the design package. So this is another document that we will train drafters how to read and interpret. All of those numbers look like gibberish right now, but they do all have a meaning. And any drafter that works for Chief will be able to tell you what all those numbers mean. Basically, it relays into the picture on the right. It's all definitions of material sizes and placements, how it all fits together. More examples of the same. One thing that we really have to watch for as drafters is when the design package has been marked up, anything that's in blue here, those are those tweaks that I was talking about, that we have to make sure that we get everything adjusted according to what the design package is telling us. So anything in blue there, he's overriding some design, and so we have to make sure we change our parts and pieces to match that. And then again, the picture on the right here. Obviously, an interior shot of a pretty good sized building again. The double X bracing in the wall gives you a pretty good indication that's probably a 40 or 50 foot tall project. You see some draft curtains hanging off the bottom of the rafter there. Yeah, lots of small pieces that all have to be detailed properly so we don't have any problem when we get to the field and then it bolts together. Roger, you're up. Okay. Does anyone have any questions on anything that I talked about? Perfect.
MBS, that's our metal building software. As referenced earlier, this is used to determine the price of the building by estimating. Engineering uses it to design each part of the building. And then it also supplies the drafter with the drawings they need for the drawing package and fabs for our plant. So we see a screenshot here. Everything that needs to be defined for what the customer ordered is listed in this program. And this is basically what many different people are using this program for to do each of their tasks. So yeah, there's two main parts that a drafter is most concerned with. The two biggest roles is one is the erection drawing. So you're going to start with a drawing like this, and this is be like a wall elevation. So it's showing all of the parts and pieces needed to assemble the building. You see some of the bubbles with little arrows. Those are sections. So a drafter is going to add sections and make sure that the builder knows how the parts are going to fit together. So the upper part is the framing. So you can see horizontal on the wall, we call them girts. They each have a little number so that the builder can go to his pile of parts and go find that part and knows where it's going. We have spacing shown on the left so they know how high that member should be. You see door locations, so the sides of the door would be the jambs and the top of the door would be headers. Below that, it would be the cladding, the exterior panel and trims, and that's showing where all those go. Up in the right corner, we see some tables. Rather than put a long string of a name, we use a little chart there where we can just put a number in a little diamond or square, and then they can look at the chart and figure out what that part is. More examples of drawings we see on paper on the left, and then example on the right, a picture of what that's like after it's been built. As Darcy had said, the engineer might tweak something, so the drafter is responsible for, adding anything that the program didn't automatically add. You might have to manually calculate the length of something or manually add something as needed. Another thing that was stated earlier is you're looking for conflicts, so you're going to have an issue with things bolting together. Drafters, on the lookout for those types of situations. Another example of a building, this would be the end wall, or the gable end of a building, and you can see it's probably symmetrical gables, so it's got a ridge and slopes two directions on the roof. And it looks like they even had a little, afterwards, put maybe a wood frame canopy we can see, which we probably did the panel for. It looks like it matches the wall, so that was probably some parts we supplied, and then they built the wood structure and put those parts onto that. So as I said, the drafter has to include sections and details with the drawing package, so the builder knows how that fits together. So we see an end wall column bolted to a rafter. You can see those parts called out, and we also call out the bolts needed for that connection. So that's a standard, that would be our primary framing, that's the main structure of the building. And then next to that would be a special detail, so it looks like there's a height change condition. And so what that is showing is the panel and trim attachment method. You know, all the individual screws and sealants and trim parts, and how much the roof panel should overhang, and a building line reference. So we have libraries of standard conditions, but a drafter will have to modify those and make custom ones for that job from time to time. And here we have some on paper sections, and then kind of out in the real world what that would look like. So, you know, part of being a drafter is being able to visualize it. So I think this kind of helps you see, you know, how those go together. We see a end wall rafter to a end wall post, that would be at the corner. And in that picture, you can see the diagonal pieces of rod or the bracing system being used. Fits through slots and has hardware to attach to. Below that, we see again that end wall column to end wall rafter. On the upper right is on a wall, we call them girts, is the horizontal framing. And so that's a section showing girts connecting to a column, the clips where holes should be located, what bolts need to be used, etc. And then the bottom right corner, we see a corner condition with the wall girt system, where we have a sidewall and end wall, and so you have two girts coming off of a corner. Just another visualization tool. We see some sheeting and trim details and kind of close-up views and sections of different situations. So where the wall panel comes to the corner, we have trim that would cover that. Where the sidewall panel meets the roof panel, and we have gutter, there's sections there. Where the end wall panel meets the roof panel, we have gable sections. We show where the end wall panel should connect, how that looks when they install that, and some different trims, headers and jambs. So the second main area of the drafter's concern is the shop fab. So we have to send drawings to the plant so they can build all the parts per the engineer's design. So what we see here is an assembly fab. So this would be a frame column. The base plate is on the left, kind of a yellowish color, and on the right would be the top of the column. So it's shown horizontally here. It'll be erected vertically. But a drafter has to look at this and confirm all the parts are in the right place, all the parts are the right size. Anything the engineer needs us to add, it might be welds that we have to tell the plant how to weld something together. We're cleaning this up. Sometimes this fab comes out and you have overplots where you have piece marks over the top of each other, and it would make it hard for the plant to read. So we have to kind of clean that up. So there's no question about what something says. Here we see an example of a primary member. Since we do, each of our buildings is pretty much a custom, like a one-off design. We rarely have a duplicate building. And so the unique thing about those is when they're designed, they're tapered members very often. So we can see it's not just straight sections. The engineer can design it as efficiently as possible by making it tapered. So here we see an example of an assembly fab. The drafter would have added that little section AA in the lower left so that the plant knows how to install some of those parts, because they're not, you can't tell from that side profile exactly where some of these go. And then the text would be all the parts needed to make that assembly. So everything on that upper picture, that's what it should look like assembled. The lower text is all the parts needed to individually make up that assembled piece. Another part of fabs would be the bill of materials. So girts, purlins, eaves struts, things like that. They're more of a bill of materials where it's not a picture, it's just the text describing how the plant is to make it. So on the fab example on the left, you can see quantity, the mark, where it's being used, the size, the length, and then it defines the holes that the plant needs to install in those pieces. Another example of bill of materials, this one would be trims. So we have trims and we kind of abbreviate them. So we see GTC as the top mark on that page, and that stands for gable trim for a CS roof. You'll see there's a color, a quantity, a length, and so a drafter has to confirm that this bill of materials is exactly what's needed. If it's not enough, we have to add, etc. Not everything is generated from the NBS software. Oftentimes the drafter will have to manually create parts. And so we have kind of libraries to start with. We also have blank fabs where we can call out part quantities of standard parts, which you see on the right there. On the left is an example of someone who had to manually come up with this drawing, manually fill out all the part sizes to make that up. So very often we need to provide a part for a building that the program doesn't give us automatically. So.
I'll relieve you here. All right, we're going to talk a little bit about trigonometry. Who remembers trigonometry from high school? Whether you're in high school or you're out of high school. Okay, so we use trigonometry in many places on a building. This slide shows you some good examples. So we use it to find the slope of our roof. So if sometimes we have to calculate our roof panel lengths, we use the Pythagorean theorem to help us do that. We also need to find the rise in our end wall panels and our slot-to-slot location for our rod bracing, which is that X bracing that you saw in a couple of those pictures. We will get into the math in the next 2 Saturday sessions. Here are some other examples, some visual examples. Again, that roof slope along the width of our end wall. And then that top right example, rise in the end wall panels. And then that far right picture is that rod bracing that we saw in the last few slides. So we use this throughout our building. Every day we're using the Pythagorean theorem. Okay, a program that we use every day is AutoCAD. Have any of you guys used any modeling software? A couple of you? What have you guys used?
I'm interior design.
Okay, a couple AutoCAD. What else?
I use Revit.
Revit.
SketchUp.
SketchUp.
Yeah.
Same thing. AutoCAD. AutoCAD. What about you?
AutoCAD.
AutoCAD. Yeah. Good. We use AutoCAD. That is our main modeling software. We use 2D AutoCAD. I don't know what you guys have been using, 3D or 2D. 2D. Yep. Okay. So we use AutoCAD. Like I said earlier, daily. We use it to MBS generates erection drawings for us, and those are CAD files. So we can go into AutoCAD and, like Todd was saying, cleaning up drawings so that you can read them. We can do that in AutoCAD. We can move text throughout that document or that file. We also use it for our detail drawings, which you can see on the right. That is a standard drawing that we have in our library. This shows you different panel and trim connections. We have all different options. I'm going to show you guys a couple layouts here. First layout is a single building, which would be a low complexity. Our layout 2 has a couple buildings, so 3-building project, and we call that a medium complexity. That third layout is going to be 2 phases and a 3-building project. So when I say phase, sometimes due to plant capabilities or location capabilities, we can't ship the entire building out all at once. Either they need all the space to erect the building, or we need to have other buildings run through our plant at the same time. So we're sending that building out in 2 different chunks. Fourth layout is going to be a 5-building complex, which multiple drafters have worked on that building at the same time. Due to, we quote a job and we say, we'll get you that building at this time, we may have more than one drafter work on a building to get that deadline or to meet that deadline. So here's a drafter's layout. We saw a little bit of the end wall here. Drafter is going to use this layout to check purlin, which are those little blue lines, vertical lines with the triangles on them. Those are going to be our purlins. Drafter is going to use this to verify that all those fabrication documents have those purlin clips in the right spot. Small building, drafting didn't do a whole lot other than verify information. Layout 2, you can see there's a little bit more going on. We see all those different colors. That's telling me that the drafter added to what MBS gave them. So MBS does generate a basic layout for drafting to use. It's up to drafting to add all those other parts and pieces to make sure that everything bolts up, lines up, and can be manufactured, can be built out in the field without welding. Third layout here, obviously a lot more. You can see this one is that 3-building. So we have our main building, our building A, and then we have a building B that's leaning up against building A, and then same thing for building C. You can see a little bit here, drafting has started making notes for themselves saying, hey, I need to make this change to my fabrication document. MBS did not give me everything that I needed in this case. And then a much bigger building, this is that multi-drafter project. So there's going to be a lot of notes on this layout from one drafter to the next, saying, hey, I'm doing something in, secondary that's going to affect the primary. So they're communicating back and forth with this layout. Obviously, a lot more little individual building, I'm going to say smaller layouts here, like this one here. We have a lot of different parts and pieces coming together all in one spot. Drafting is going to use this to make sure that building A is connecting to building B and building C, all in the same location. Any questions on AutoCAD? We'll go a little bit more in depth the next few Saturdays. But any questions so far? Okay. We also use a different program called Bluebeam. So Bluebeam is our PDF editor. If I have like an example on the left, here is a set of fabrication drawings. This is what we use to communicate with the plant. One on the left, how we want all the parts and pieces to go together. On the right side there's a text file that shows the plant exactly what size dimensions, where to put holes on all those different parts and pieces. In red, you can see, it might be easier to see on your pages than on the screen, but that is going to be stuff that the drafter has marked up for the plant to change from what MDS gave us. On the right there, that is a set of our bill of materials. This is showing a girt, and you can see it is crossed out and there are different hole punches. Drafting based off of either their layout or doing a calculation for hole punching on our horizontal members, so our girt, has decided that what MDS gave isn't quite right. We're going to adjust that punching just a little bit. We also use Bluebeam to mark up our erection drawings. So this is a quick way for drafting to say, hey, I need to change something in AutoCAD, but I don't want to go into AutoCAD and do it quite yet. I want to mark up this set of drawings for myself, and I want to show the changes, which is in red. You can see there's little red markups. In yellow, that's going to be something that the drafter has verified, so they agree with what MDS has given them. And then in blue, that could just be something they write to themselves to help go through the drafting process. Like you can see that blue right triangle across that X bracing, they're using that to help them find their right triangle, or to find the calculation for their rod bracing lengths. Okay, we are going to do a little fun activity. So I'm going to have everyone break out their phones. I want to know how many of you have played Kahoot? A few of you? Okay, so you're going to go to Kahoot. You just type in Google, go to Kahoot. Kahoot. I'll pull it up here. When you get to the website, you are going everybody continues to log in. Everybody getting in there all right? Anybody need any help? Give you Josh, are you?
Okay. Yep, we're good.
Material. Here the Right, I'm gonna go ahead and get started. Again, quickest to get the correct answer. What is number 2 referring to on this picture? I have the picture on your All right, peak. Number 2 is peak. Let's see who's at the top. Oh, it's a close one so far. Number 12. Abel. See if we still have the same leaders. All right. Question 3. What is number 16 referring to? Sidewall. All right. Still pretty close up here. Number 4. All right, Eve. Number 4 was our Eve. Number 17.
Prove me wrong.
Building width. Number 1. Building length. Good job. All right, Gage, you're in the lead. Number 11. Wall. Number 11 is our end wall. All right, Colby, you're in the lead. Only a couple more questions. Number 13. Height. 13 is our eve height. All right. Number 5. Hey, ridge. 5 is our ridge. We've got a couple players on a hot streak. Let's see if they can win. Number 15. Eve, good job. All right, last question. Number 9. All right, sidewall. Okay, drum roll. Michelle in third. Oh, way to go, guys.
Okay, So I'm just going to talk a little bit about what our work environment is like here at Chief Buildings, what our mission statement is, what some of our company values are. So the biggest one that we like to talk about is our mission statement. So here at Chief, it is our mission to provide unparalleled personal attention to meeting the needs of our customers while treating all stakeholders with dignity and respect, thereby ensuring our strength and stability. So there are three major points that we like to point out. First of all, we're very relationship driven. We want to have great relationships with all the customers that we work with. So we want to always provide excellent customer service to them. Second of all, we want to treat all stakeholders with dignity and respect. Who are our stakeholders? Well, at Chief, our stakeholders are all of the employees who work here. It is our builders, it's our suppliers, it's the families of the people who work here, the families of our builders, and it's the communities where we do business. So really when we say treat people with dignity and respect, we mean everybody, not just the ones that work for our organization or buy product from us. We believe if we do those things, build relationships, treat everyone well, it will only strengthen and stabilize our organization. Okay, family values are at our core. So again, we are a family-owned organization, third generation family-owned. So what does that look like working for a family-owned organization? First of all, we allow flex time here in this office. So flex time means that we might have people who, need to leave at 3:30 in the afternoon to go pick up their kids. So maybe they come in at 6:30 in the morning or something. So we can provide some flexibility. We do like employees to work most of their shift during our hours of operation. So the majority of your shift should be worked between 8 and 5, but we can be a little bit flexible for people's family lives, which is really nice. If you have to leave to take your child to an appointment, or maybe you have your own doctor's appointment, maybe you have a legal appointment, whatever, things come up in life, maybe there's a death in the family, illness, and you miss a day of work or you miss an afternoon, and instead of using your PTO time, you want to make up that work somewhere else in the work week, we do allow people to do that as well. So those are just some examples of how we can provide flexibility with our flex time in the workplace. We believe in work-life balance, so we want you guys to, enjoy coming to work. We want you to go home not stressed, not thinking about work. We want you to be able to have time to do the things you enjoy when you're not here. So, yes, we work hard when we're here, but we also want you all to we also understand you have families and lives outside of this place, and we want you to be able to enjoy that time as well. So we're stakeholder centric. Again, going back to that mission statement, we really focus on our employees, having involvement from our employees, investing in their growth and development, and taking care of our people. And then here at Chief, and this is something I can attest to, when I walk around and ask most people what their favorite thing is about working here, they tell me it's the people that they get to work with every day. I believe that's true. I think we have amazing people, and I do feel like here at Chief, your coworkers care about you and want to see you succeed, and they're going to help you. They're going to help you to do that. Getting involved, company events. So this is just some pictures from different company events that we have going on throughout the year. This first one up here is our company picnic. They're playing bingo. Darcy with all the balloons. That's a big United Way campaign that we do. We go on we have a tanking trip every year that you can sign up for and go along on. We get involved in some golf tournaments. People get to go out and golf. Here in Grand Island, downtown, it's a concert series here in Grand Island, and they do an event at Big Red Treats, where if you go down and you're wearing a Chief t-shirt or a Chief hat, you can stop into Big Red Treats and get a snack for you and your family. There's a big butt contest. The picture on the bottom is from a chili cook-off that we had, so we just kind of try to do some fun events throughout the year. Getting involved, you could serve on a committee, so that'd be another great way to get involved with our organization. If you come work for us, Kristen up here, she was volunteering for our United Way campaign, and her job was to walk around and try and sell goodies off of her cart. It was a travel theme, so we were calling them in-flight deliveries. She was in charge of delivering in-flight deliveries that day. There you can see Jeff, Dwayne, Darcy, they're all cooking out on the grill. We were probably having a 4th of July cookout or something. They're on the food committee, so a lot of times they get roped into cooking for our team. And then over there, that's another United Way campaign activity. We did a mini golf competition. So we gave each team some materials to build their own mini golf hole. We had them throughout the office, Employees could pay to play a round of golf, and then all of the money that we earned from them playing golf got donated to charity, so. Getting involved in activities. This is just an example of some of the activities that we have had in the past, that we may have again. So there's a sand volleyball team up there, volunteering for road cleanup. Every year around the state fair, they do a big road cleanup. So if volunteering in the environment is something you're passionate about, you can get involved in that. We've had kickball team. We have a golf tournament every year. So that picture on the bottom is from that golf tournament. So. Getting involved, we have a mentorship program. This program is still it's still being developed a little bit, I will say. But the purpose of the program is kind of to help new employees, pair them up with someone who's more experienced that can kind of help show them the ropes, make them feel welcome, help them transition into working for Chief. Make the most of your career. So over there, you'll see some things that we can offer here at Chief. We do provide on-the-job training. Darcy talked about how extensive that training really is. We sit in there for months. You work with Ashley in what we call the incubators for a long period of time as well. So we do provide that on-the-job training. We have opportunities for growth and advancement. I think many of you have heard about that tonight as well. You know, Dwayne, Darcy, Todd, Ashley, myself, we all worked in one department or another and have had opportunities to grow and advance and learn in other areas of the company, which I think is really neat. We have those career paths. So, you know, you may start in drafting, but there may be opportunities for you to move into estimating or project management if that is what you're interested in. Maybe you want to work in customer service. Maybe you want to stay in drafting and you want to become a drafter 1 and then a drafter 2 and then a drafter 3, and maybe you want to be a checker. Maybe you want to be a group leader. Maybe you want Dwayne or Darcy's job. Maybe you want Ashley's job. You want to be the next training lead. So if you're really passionate about drafting, there are opportunities to grow and stay in drafting as well as other areas of the company. So we have this little chart here. This is just kind of what we're looking for from employees who do want to advance their career. So are you a change agent? We are, you know, growth minded. We're constantly changing and making updates, making improvements because we want to remain competitive. So we need people that can adapt and be flexible, make those changes with us and be positive about it. Empathetic, you know, if you're going to work well with others, you've got to be a good listener. You've got to be curious. You've got to live our mission statement, treat everyone with dignity and respect. Little things, you know, I talked about the different ways you can get involved. Do you volunteer? Are you part of the mentor program? Do you serve on any of those committees that we talked about? Growth minded, so I kind of touched on that already, but are you unafraid of failure? Do you invest in yourself and your own growth and development? Do you put the time in to become a better, productive employee? Results oriented, so we do look at that. You know, you've got to be performing as well. You've got to be learning, growing, retaining the information. So we do look at job performance. Are you accountable? So can your supervisor count on you to show up every day and do the job that you've been assigned? Can your teammates count on you to show up every day and do your part? And then again, mission driven. So treating everyone with dignity and respect and providing that unparalleled attention to meeting the needs of our customers. Okay, next steps. If everybody will go back to the beginning in their binders, you should see a sheet of all of your next steps in it. I'm actually going to read through some of that with you. Okay. So exploratory presentation. If you're here, you've already done that part. So congratulations. Step 1 is done. This Saturday, we are going to have Introduction to Chief Drafting, Session 1. So that's going to start at 8 a.m. this Saturday. You'll go to the same building, same room that you're at right now for this exploratory session. So session 1 will be Saturday from 8 to noon. We're going to hand out some homework and we're going to hand out a spatial ability test, and we want you to do those things at home between now and Saturday and bring them back with you on Saturday morning at 8. Okay, then the following Saturday on April 12th, we're gonna have another session. That's gonna be from 8 a.m. to 12 p.m. We'll have you bring any homework that we assign this Saturday to that second session. So again, we wrote in there when your homeworks are due, so make sure you're following those, make sure you're bringing those, because that is part of the completion for the program. So when we say, in order to get the money, you have to complete the requirements of the program, the homework, the spatial ability tests, those are all part of those requirements that we want you to complete. So make sure you are doing those, make sure you're coming prepared to your sessions with that homework, with spatial ability test. After session 2, we'll schedule 2-hour job shadows with each of you. Those will take place April 14th from the 18th, and if we can't get everybody in on those dates, then we can open up some additional time slots the following week. We want you, if you're interested, after going through this program, if you're interested in applying for a full-time position as a drafter with us or a drafting apprentice with us, we do want you to fill out a formal application online. That application is going to open up on April 10th. We're going to conduct interviews for qualified applicants April 21st through May 1st. We're going to make offers to select candidates by May 2nd. The start date for hired individuals is to be determined, but it will be sometime in May. And then we'll mail out a certificate of completion and a $300 payment. And then those of you who come work for us full-time after this program will receive a $500 bonus after you work for us for 30 days full-time employment. So I know that's a lot of information. Any questions on the timeline or the schedule? No questions? Okay. We're going to go ahead and any other questions about anything else that we talked about tonight? About Chief, about the program, about drafting? Okay, then Ashley's going to hand out a homework assignment and spatial ability. You can use your binders to complete your homework assignment. Those are meant to be a resource for you. You know, there's a reason that we gave you a copy of all the slides. When you're a drafter for us, you're going to have a lot of resources that you can refer to. So we think it's important to start giving you those resources now, see how you're able to utilize them on these assignments that we give you. So use your binders. It's not cheating. That's why we provided them for you.
That spatial ability test is meant to be done as a time test, 20 minutes.
Okay, Dwayne is just saying that the spatial ability test is a time test. You should time yourself take it home, time yourself for 20 minutes, get through as much as you can, and when the timer stops, put the pencil down. Josh, Trey, do you have any questions for us there at either of your locations?
No, I think we're good and you follow, Taryn.
Okay, great, thank you. Josh?
We're all good in Lincoln.
Okay, sounds good.
Have a good evening.
Two. Okay, if we don't have any more questions, we'll
No
go.
questions? Last chance for questions?
Oh, one last thing, we will have breakfast for you Saturday morning. So bring your appetites, we'll serve breakfast. All right, we'll see everybody on Saturday. Thank you.
Thank you.
Oh, God, no, don't ask me a hard one.